Welcome to CCNA course presentation. In this session, I am going to talk about redundancy protocol called HSRP, Hot Standby Router Protocol. First, I'll talk about concept. Later, I will show practicals. Let us start.
So what is redundancy? Redundancy having multiple connections to same destination. Let us take this scenario. We have two routers in an office. So two routers having internet connections and router 1 default gateway address, that is router 1 LAN interface address is 192.168.10.100. Router 2 LAN interface address 192.168.10.200. Now we need to assign default gateway for PCs in LAN. Router IP address is the default gateway. Now which IP address we need to assign as a default gateway? 1.10.100, 192.168.10.100 or 192.168.10.200. If you assign 192.168.10.100, routers a PC will send packet to router 1, router 1 will forward packet to destination, right? Okay, communication will take place. What happens if this router is down? If this router goes down, we need to change a default gateway to this address 10.200. So then if you change IP address to 10.200 default gateway, then packet will be routed to router 2. Router 2 will forward this packet to destination, right? So assume in this LAN there are 1000 computers, 1000 computers. For all these computers, if you want to change default gateway, it is hectic, it's a tedious job. So that's why Cisco has developed a redundancy protocol called HSRP. So let us discuss about HSRP. What is HSRP? Hot Standby Routing Protocol. HSRP is a Cisco property protocol. It provides router redundancy, right? Routers are grouped together to work as one virtual router. So both routers will work as one router, and group ID is a range given from the range. We can give group ID from 0 to 255. Okay. Hello. In this section, I'm discussing about redundancy protocol. So what is redundancy? Redundancy having multiple connections to same destination. Like in this scenario, we have two routers connected to internet. Router 1 IP address, LAN interface IP address is 192.168.10.100 and router 2 LAN interface IP address is 192.168.10.200. Right, we need to assign default gateway for these PCs. So which IP address? Router 1 IP address or router 2 IP address? If you assign router 1 IP address as a default gateway, that is 192.168.10.100, then PCs will send packet to router 1. Router 1 will forward this packet to destination. Communication will happen. We can access internet, right? What happens if this router goes down? So communication is stopped. So what we need to do? We need to change default gateway to 192.168.10.200, router 2 address, right? Then packets will be routed to router 2. Router 2 will forward this packet to destination. Communication will happen. Communication will take place, right? So if there are multiple computers, like a large network, like thousands of computers are there, at that time, if you want to change default gateway, it is hectic, it's a tedious job. So that's why to overcome from this problem, Cisco developed first hop redundancy protocol called HSRP. So let us discuss about HSRP, Hot Standby Routing Protocol. So Hot Standby Routing Protocol is a Cisco proprietary protocol. It provides router redundancy, means we can have multiple routers, okay? And routers are grouped together to work as one virtual router. So group ID range is 0 to 255. Default is 0. A router can be a part of multiple groups, right? And in that two routers, one router will act as active router, other one will act as standby router. Active and standby, two roles of routers, okay? And so it is like this. Both the routers we have to keep in a group, we have to configure in a group, and the group number can be 0 to 255, any number from this range 0 to 255. Here example we have taken as 47, right? So now one router, we have to configure IP address on both the routers, that is called as virtual IP address, and this virtual IP address will be the default gateway for all PCs in LAN, right? Now what happens now, there are two roles of routers, active router and standby router. So what active router will do, it will forward traffic to destination. So when this PC is sending packet to active router will forward packet to destination. If this active router goes down, then a standby router will become active and then packet will be forwarded to destination. Clear? Okay then. Now this PC 192.168.1.250 as a default gateway we have assigned. Generally, this PC will generate ARP request. 192.168.1.11 is the source IP, MAC address is A, and destination is the default gateway address. What is the MAC address of destination? All F will be there. This is ARP request. So when this PC generates ARP request, it goes to all the devices. It's a broadcast request. Who should respond? Active router should respond. Active router will respond. Will it send its HSRP MAC 0000C 07 AC2F. This 2F is basically a group ID, right? Now, say this PC gets a default gateway address MAC address, that is a default gateway IP address, and the further HSRP MAC. Okay, now what this PC will do, who send this address, the MAC address to this PC router, active router. So packet will be forwarded to active router. Now there is a election process in HSRP, active and standby election process. HSRP is an application layer protocol. UDP uses UDP port number 1985 and multicast address 224002 for hello packets. Router, active and standby router will exchange hello packets, and hello will be sent in every 3 seconds. If active router goes down, it will not send hello. Standby router will wait up to 10 seconds. After that, standby router will become active. So standby will play that role as active router. And now who should become active? Whichever the router has highest priority, that router should become active. If priority value is same, tie, then physical interface IP address router will become active. Highest physical interface address. Highest physical interface IP address router will become active. Okay, so like this here, 192.168.1.100, 192.168.1.200. Now 1.200, this router C will become active. Now if you want to see this, these are HSRP hellos, will be sent in every 3 seconds, right? Now how to configure HSRP? You have to configure in LAN interface. You have to go to the interface, LAN interface, and then give command standby group number IP virtual IP address. And default priority value is 100. So if you want to make a router as active router, you have to increase priority value, and for that syntax standby group number priority, and we have to give the priority value, higher priority value to make as active, right? Like this 150. So now this router will become active, fine. And now for some reason I want to make router C as active. So what we have to do, we have to increase priority value as higher than this 150, right? If you give 170 as a priority value, then what happens? Router C will become active? No, because this election is non-preemptive. If you increase priority value, router C will not update, will not inform router B that it has higher priority value. So for that we have to give command as preempt. So if you add this command standby group number preempt, then this router will inform the router B, the neighbor router, that it has higher priority value. See, like this, my priority value is high, I will become active. So after giving this preempt command, because HSRP is non-preemptive, there is no automatic re-election, right? Now this becomes active, and the active router goes to standby. Over? Okay. Now both the routers will exchange hello, active router and standby router. What if active router goes down? Standby router will wait up to 10 seconds, 3 hello packet plus 1 more second, 10 seconds, then standby router will become active. Now in this scenario, both the routers are working fine, no problem. Now say this, WAN link goes down. If this internet link goes down, then what happens? Communication will not happen. PCs will not be able to access internet. Packet will be routed to active router will drop that packet. Communication will not happen. So what we have to do is, we have to tell this active router, if your WAN interface if it goes down, you have to inform standby router to become active. that is called as tracking command. So if you configure tracking command, active router will inform standby router to take that role, to play that role, active router. Right, standby, group number, track, serial interface, serial 0, and this 31 is a decrement value. Means we are telling this router, you monitor your serial 0 interface. Whenever it goes down, you decrease your priority value by 31. 150 minus 31 is 119. See this? Then this router B will inform neighbor router, router C, to become active. So this is the syntax for tracking command. Standby, group number, track, interface type, serial, whatever the interface, and the number with priority value. This priority value is called as decrement priority value. And to decrement priority value from HSRP whenever the interface goes down. And very important, preempt command is pre-required on both routers for this command to work. Means if you want to use this command, first you have to have a preempt command, standby group number preempt. Then this command will work. Now let us see this configuration for active and standby router. So we have, according to this scenario, right? So router 1, router 2. So these two routers we will configure, these two routers will keep in the same group, right? And then I want to configure a group number as 47 or anything, any number we can use. So let us take group number I want to use as group ID as 10. Okay, and I want to give virtual IP address, virtual IP as 192.168. It should be in the same network, 10.250. Any IP address in the same, it should be in the same network. Fine. Okay, so now these two routers we have to keep in the same group, right? So let me just put in a group these two routers, right? And virtual IP address is 10.250 and group ID is 10. Okay, now what is the default gateway for PCs? So default gateway for these PCs are virtual IP address 192.168.10.250. Like this we need to assign. Okay, now let us take these two routers. So before this HSRP configuration, we have to configure routing protocol on these two routers. So to access internet, which routing is required? Default routing. So we have default routing. See this, show IP route. I have already configured default route in this router. See this, S*000 and exit interface, so S0 by 0. So here that we can configure in this scenario. According to this scenario, we have S0 by 0, right? So anything, it can be any interface, need not be the same interface all the time. So we can just take any interface according to this setup. Let me add that S000, right? And next we have similarly on router 2. Now I want to configure HSRP on both the routers, router 1 and router 2. Okay, so how to configure? Configure terminal, interface FA0/0 LAN interface, and the command is standby group number, whatever the group number you have configured, right? Group number 10, then IP address, which IP address? Virtual IP address 192.168.10.100 is the LAN interface. Now we have to give virtual IP address as 10.250. Standby group number and priority value. I want to make this router as see this. In this scenario, router 1 has 10.100 and router 2 IP address is 10.200. By default, router 2 will become active because of highest IP address. Now I want to make router 1 as active, so I have to increase priority value. So I'm giving priority value as 150. And one more command. So see this, the moment you configure standby priority value, it has become active. So I want to configure preempt to go for real automatic reelection. Standby 10 preempt. Done. Then similarly, I have to configure in router 2. Right. So configure terminal interface FA0/0 LAN interface. Then standby, same group number must be same, right? To keep both the routers in the same group. Standby 10 IP virtual IP 192.168.10.250. Okay. Then standby group number 10, one sec, standby group number priority value, not necessary, just for easy understanding. By default it is 100. Router 1 we have given priority value as 150, and in just for our understanding purpose we can add, okay, priority value. Standby, then group number, one sec, group number 10 and preempt. Over. That's it. Now let us check the configuration, verify the configuration, and see the status of the router. So show standby is a command. Show standby. Can you see this? Router 1 has become active. What about router 2? Standby router. Can you see this? Router 1 has IP address 10.100 and router 2 has 10.200. Right? Now in this router 1 I'm giving show standby command. It is telling I'm in this group and my status is active and virtual IP address is 192.168.10.250. Okay, so standby router is 192.168.10.200, that is router 2, and we did configure virtual IP and a priority value as 120, right? And this 150 is a priority value for active router. Right, now let us check in router 2. What is the status? Show standby. Show standby. So see this, state is active. Sorry, state is standby of this router 2. And who is active? Router 1 is active router. Priority value for router 1 is 150. Right, now to verify, what we can do is we can trace route, we can ping, we can whatever, like we can telnet. Now what I'm doing is from this PC I'm telnetting to virtual IP address. Telnet 192.168.10.250. So this, who is responding? If I telnet, router 1 is responding because router 1 is active router. That's why it is showing I'm active. So router 1 is responding for this request. Clear? So this is router 1. Now what I'm doing is I'm going to router 1. I'm shutting down that interface of router 1, LAN interface. Then what happens? It will not send hello packet. If it does not sending hello packet, router 2 will wait. See this goes down. Then router 2 will wait for 10 seconds and router 2 will take the role of active. Right? Now see here. If you press enter, it will disconnect. It has come out, right? Now see the status of router 2. Show standby. Can you see now? Router 2 is active. State is active. Standby router unknown because we have only 2 routers. At a time we can take 2 routers. One will be active and the one will be standby. Right. Now what happens if I just again from the PC, if I telnet to the same virtual IP address, see I'm not changing any address, telnetting to virtual IP address. Now who is responding now? Router 2 is responding because router 2 is active. Clear? So now I'll make this interface up again. So what happens now? If that router comes back? Yes, nothing. Router take, because of preempt command, both routers will go for election again and router 1 will take that role of active. Fine. See this, show standby, right? Speak, router is still in the election process. Fine. Now what happens to this router? Router 2, still active because they go for re-election. Then again after re-election, router 1 will become active. Sorry, router 2 will become standby. Right? Now let us say now show standby. See this now, router 1 is active. Then who is a standby router? Router 2 is a standby. Clear? Like this, if this interface goes down, router 2 will become active and traffic will be forwarded to router 2 and router 2 will forward traffic to destination. Automatically, don't need to change anything on the PC. Don't need to change anything on the PC. Automatically, packet will be routed to router 2. Router 2 will forward that packet to destination. Clear? And then tracking command. Right, now router 1 is good, router 2 also good, both are working fine. Suddenly this interface goes down. WAN interface, this interface goes down. Then what happens? Communication is stopped. So what we have to do now? We have to set tracking command. So where to configure? In active router. Fine. So I'm configuring tracking command in active router. Interface fs0/0 LAN interface standby group number 10, sorry, standby group number, then track which interface? Serial 0/0, right? And if it goes down, it has to decrease priority value by 40, right? Now see this, to verify, show standby. If you give this command, it will show last but one line, a tracking command. See this, interface is up. That's why the priority value is 150. Okay, if this interface goes down, it will decrease priority value by 40. It will become 110, right? Okay, now let us see. So who is accessing now? See this, who is active? Router 1 is active. Clear? Right, now what I'll do, I'll just shut down the interface. That is which interface? WAN interface S0/0/0. Right, if you shut down this interface, then what happens? Automatically the router 1 will decrease priority value by 40 and 110. It will become 110 and it will inform router 2 my priority value is 110. Then router 2 will become active. Now see this, if I press enter in this PC, right, it will disconnect this session. Fine. Now again, if I telnet to the same virtual IP address, now who is responding? Router 2 is responding. Now see this in router 2, show standby status. Router 2 is active because it has priority value as 120. Correct? What about router 1? Standby router. Why? The priority value is 110 because 150 minus 10, 150 minus 40 is 110. Now see here, again, show standby. See the status of this router. Right? It is status is standby, priority value is 110. 150 minus 40. Correct? Like this, tracking command works if this router 1, that active router serial interface goes down, internet connection fails, then it will inform neighbor router, that standby router, to become active. Router 2 will become active. What happens if the link comes back? Internet comes back, right? So interface FS serial 0/0. Now no shut. Assume that WAN link comes up again. Then what happen? Again re-election will happen. Clear? So router 2 will say that, okay, you are having, so what happens if this WAN link comes back? Router 1 will say my priority value is 150. It will not decrease priority value if that link is up. Fine. Now let us check that. Show standby. See here, state is active because priority value is 150. Now it will not decrease because state is up. Whenever the state in the interface goes down, then at that time it will decrease this priority value with 40. Right? Now if I check in the PC, see this, it disconnects because router 2 is not active now. Who is active? Router 1 is active. Clear? Like this, tracking command works, and this is HSRP.
I hope this has been informative for you. Thank you for watching this video.